Okay, we're going to derive some more rules. We were just multiplying them together, so now we're going to divide. So this part right here is pretty straightforward. This is always just going to be R1 over R2. Here, however, I've got an imaginary number in the denominator, which we're not allowed to do because it's a radical. So back to the conjugate we go. So this becomes cosine of beta minus I sine beta, cosine beta minus I sine beta. Okay. The denominator, the center terms are going to just cancel out because it's a difference of perfect squares. Okay. So we've got R1, R2, and then in the numerator, we've got a nice long one. We'll come back to the numerator. Cosine squared beta, the center terms cancel out. I'm left with minus I squared sine squared beta. That becomes positive. Hey, look, a nice happy little identity. So that's all going to become a 1 in the denominator of the question. Now the numerator is going to become cosine alpha, cosine beta. Wonder if you're sensing a trend from the last question. Minus I cosine alpha sine beta. In second terms. Plus I sine alpha cosine beta. Minus I squared sine alpha sine beta. That becomes -1. Multiplier makes that a positive. Now we're going to do just exactly what we did last time. We're going to match reals with reals. And that makes cosine alpha cosine beta plus sine alpha sine beta. And then imaginaries to imaginaries. I'm going to pull the I out just like I did before, I, and I'm going to put the positive term first, and then I'm going to put the cosines first. It doesn't really make a difference so long as you recognize that we're going to be looking at addition and subtraction rules again for trig functions. So I, and then this becomes cosine, I'm just looking at this one first right here, cosine beta, that's that term, sine alpha, that's that term, and then we're going to subtract, and then I'm just going to write the cosine alpha sine beta. Okay. And then this is all over this right here, which turned out to just be a 1. Yay! All of this right here is going to simplify down. Oh, don't forget our R1, R2 up front. So R1 over R2 times, we don't need a denominator anymore because it's just all over 1. Cosine rule, or not cosine rule, the cosine additive identity here. So if it's a plus here, that means it's a minus. So cosine of alpha minus beta plus I, and then this one's the sine one, sine of alpha minus beta. Okay, and that becomes our rule. When I divide two vectors or complex numbers that are vectors that are in complex form, I can use this. R1, R2, cosine alpha minus beta plus I sine alpha minus beta. Another rule, which I'm going to have you guys kind of derive on your own. I want you to figure this out, and then it'll be the checkpoint for when we come to class tomorrow. So we'll have the activity from the first sheet that we'll work on, and then I'll check this to see if you did this. So let's say that instead of just having some complex number z sub 1, let's say I have z sub 1 to the negative 1, or in other words, 1 over that. So there's a question earlier in 10.2 from the first section we were working on that was like this, and I said, just go ahead and use the conjugate at this point. But what we can do is exactly what I said. Use the conjugate, and we're going to generate a rule. So cosine alpha minus, looks like a 2, I sine alpha. And of course, we multiply by 1 in this form. The denominator becomes it becomes cosine squared alpha plus sine squared of alpha, which is that. Hey, look, it's a 1 again. Okay, and then the numerator just becomes cosine alpha minus I sine alpha. So the rule is that if this were my original complex number and I wanted to divide 1 by it, it becomes 1 over the magnitude times, this is all just going to become the numerator, over 1. So times cosine alpha, which is just like it was when it began, but now it's minus the second term instead of adding the second term. So here's an example. If I have these two complex numbers, I want you to write them in cis form. Careful, this guy has a plus 0i. And then I want you to use the rule that we generated up here for any vector divided by another vector in polar form. I want you to see if you can use that rule down here. And then we'll check our DP formula sheet, but I think this might be on our DP formula sheet too. I'm pretty sure at least the multiplying and the dividing ones are. So we'll come back to those. So what I want you to do is put them into polar, so practice from the other day. And then I want you to use the rule up here where we subtract or we add the values of the angles from cis form, and then we divide out the magnitudes. So this one right here, this is your try it. This will be what I check for tomorrow in class. Okay. Have a great evening. We'll see you tomorrow.